Welcome to the Web Security Bootcamp channel, a series of SQL injection tutorials. In the previous video, we covered the theory behind blind SQL injection, including conditional responses, conditional errors, time-based techniques, and out-of-band attacks. If you haven't seen that lesson yet, you'll find a link in the description. In this video, we'll apply those concepts by working through the PortSwigger Lab blind SQL injection with conditional responses. We'll analyze the vulnerability, identify how the application behaves when our injected conditions evaluate to true or false, and use that information to retrieve sensitive data step by step. As always, this demonstration is performed in a safe training environment for educational purposes only. Only test systems that you own or have explicit permission to assess. In this lab, the SQL injection vulnerability exists inside the tracking cookie sent with every request. The application doesn't reveal database errors or display query results, making this a blind SQL injection challenge. Instead, we'll rely on small differences in the server's response to determine whether the SQL condition we inject evaluates to true or false. By asking the database a series of carefully crafted questions, we'll gradually extract the administrator's password and use it to log into the administrator account. I'm currently in the PortSwigger training lab. I click on the Tech Gifts category and a welcome back message appears on the page. This message is crucial for this lab. It appears because the website recognizes us using a cookie. A cookie is a small piece of data that a website stores in the user's browser. When we revisit the site or navigate to another page, the browser automatically sends this cookie back to the server. In this lab, we're interested in the cookie name tracking ID, because it's included in a SQL query on the server and determines whether the welcome back message is displayed. Now I'll switch to Burp Suite and open the HTTP History tab. This tab shows the history of all HTTP requests that the browser has sent through Burp. This means we can see which pages were visited, what parameters were sent, which cookies were included, and what response the server returned. Now I'll return to the browser and click Home to generate a new request to the home page. Back in Burp, I find that request in the HTTP History tab, select it, and send it to Repeater. In the cookie header, we can see several cookies. We need tracking ID because this is the value we are going to change. We can modify this cookie and immediately observe how the server's response changes. First, I send the original request without making any changes. In the Response tab, I search for the welcome back message. We can see that it's present in the server's response. This tells us that the current tracking ID value satisfies the condition the application expects, so the message is displayed. Now I'll add the first payload to the tracking ID value. This payload injects a SQL condition that is always true, for example, 1 equals 1. Next, I select the payload and press Ctrl-U to URL encode the special characters. Then I send the request again. In the response, I search for welcome back once more. We can see there's still one match. This confirms that when our injected condition evaluates to true, the welcome back message remains visible. Now I'll replace the payload with a different one. This time the condition will be false, for example, 1 equals 2. I URL encode the payload again using Ctrl-U and send the request. This time Burp shows that there are no matches. The welcome back message has disappeared. This is the key indicator of a blind SQL injection vulnerability. The application doesn't display database errors or query results directly. Instead, its behavior changes depending on whether our injected SQL condition evaluates to true or false. When the condition is true, the welcome back message appears. When the condition is false, the message disappears. We can use this difference as a communication channel with the database, allowing us to test conditions and gradually extract information one step at a time. Now we move on to the next step. We want to confirm that a table named users exists in the database. To do this, I remove the previous payload from the tracking ID value and add a new one. Let's break down how this payload works. At the beginning, we keep the original tracking ID value. The single quote closes the string in the SQL query that the application builds on the server. Next comes our injected condition. The subquery attempts to select the letter A from the user's table. If the user's table exists, the subquery successfully returns A. The outer comparison then checks whether A equals A. If the comparison is true, the application displays the welcome back message. If the table doesn't exist, the subquery fails, the condition isn't satisfied, and the message doesn't appear. It's important to understand that the letter A has no special meaning. We could just as easily use B, X, or any other value. We simply compare the same value on both sides of the equals sign. Now I select the payload and press Ctrl U to URL encode the special characters. Then I send the request. In the Response tab, I search for the welcome back message again. We can see one match. I click it and Burp highlights where the welcome back message appears in the server's response. This tells us that the condition evaluated to true. The subquery executed successfully and returned a result, confirming that the user's table exists, and the application continues to display the welcome back message. Now let's check whether the user's table contains a user named administrator. I replace the previous payload with a new one. The logic is almost identical. This time, subquery searches the user's table for a row where the username is administrator. If such a row exists, the subquery returns A. The comparison A equals A evaluates to true, so the application displays the welcome back message. If no administrator user exists, the subquery returns no rows. As a result, the comparison isn't satisfied and the welcome back message disappears. Now we need to determine the length of the administrator user's password. To do this, I delete the previous payload and add a new one. Within this payload, we again use a subquery select A from users. This time, however, we add two conditions. The first condition, username equals administrator, tells the database to find the user named administrator. The second condition, length of password is greater than 1, checks whether that user's password is longer than 1 character. So we're asking the database, is the administrator's password longer than 1 character? If the answer is yes, the subquery returns the letter A. The comparison A equals A then evaluates to true, causing the application to display the welcome back message. Now I select the payload and press Ctrl U to URL encode the special characters. Then I send the request. In the Response tab, I search for the welcome back message. We see one match. This means the condition is true, so the administrator's password is definitely longer than 1 character. Now I change the number from 1 to 100 and send the request again. This time the welcome back message is no longer present in the response, therefore the condition is false. The password is not longer than 100 characters. Now I change 100 to 50 and send the request again. Again, there are no matches, so the password is not longer than 50 characters. Now I change 50 to 25 and send the request again. Once again, the welcome back message is absent. This tells us that the password is not longer than 25 characters. Manually changing the number each time is slow and inefficient. Instead, I'll send this request to Intruder. Intruder is a Burp Suite tool that automatically sends large numbers of similar requests. We simply mark the part of the request that should change, and Intruder substitutes different values and sends the requests one by one. In our case, we only want to change the number in the condition. Length of password is greater than 25. In the Intruder tab, I first click Clear Section Sign to remove any positions that Burp selected automatically. Then I highlight the number 25 and click Add Section Sign. The section sign symbols indicate the position where Intruder will insert different values. Now I open the Payloads tab. For payload type, I select numbers because we want Intruder to insert numeric values automatically. In the From field, I enter 1, so the first request will test whether the password is longer than 1 character. In the To field, I enter 25, meaning the last request will test whether the password is longer than 25 characters. I leave the step value set to 1, so Burp tests every number in sequence, 1, 2, 3, 4, and so on. For max integer digits, I enter 2 because the largest value we're testing is 25, which contains 2 digits. Now I click Start Attack. Burp now starts sending the requests automatically. Each request is almost identical, but the number inside the condition changes. For example, length of password is greater than 1, then length of password is greater than 2, then length of password is greater than 3, and so on, up to 25. When the status at the bottom changes to finished, it means intruder has completed the attack. Now we need to identify the request where the server's response changes. To do this, I look at the length column. The length value shows the size of each server response in bytes. When the response includes the welcome back message, the page is slightly larger. When the message is absent, the response is slightly smaller. By comparing the response lengths, we can quickly determine where the injected condition changed from true to false. First, I select a response with a length of 11,547. In the Response tab, I search for Welcome Back. There are no matches. This means the message is absent, so the condition evaluated to false. Now I select a response with a length of 11,608. Again, I search for Welcome Back. This time we find one match and Burp highlights the message. This means the condition evaluated to true. Now let's look at the point where the result changes. For the value 19, the response is larger and the welcome back message is present. This tells us that length of password is greater than 19 is true. For the value 20, the response is smaller and the welcome back message is absent. This tells us that length of password is greater than 20 is false. If the password is longer than 19 characters but not longer than 20 characters, then its length must be exactly 20 characters. Now we move on to determining the password itself. We already know that the administrator user's password is 20 characters long. The next step is to determine the value of each character, one position at a time. I return to the Repeater tab, remove the previous payload, and enter a new one. Let's break down how this payload works. The subquery searches the user's table for the user named administrator. The substring function extracts part of that user's password. The function takes 3 arguments. The first argument, password, is the column that contains the password. The second argument, 1, specifies the starting position. In this case, we're checking the first character. The third argument, 1, specifies how many characters to extract. Here, we extract only 1 character. The extracted character is then compared with the letter A, so we're asking the database, is the first character of the administrator's password equal to the letter A? If the answer is yes, the condition evaluates to true, and the welcome back message appears in the response. If the answer is no, the condition evaluates to false, and the message does not appear. I select the payload and press Ctrl-U to URL encode the special characters. Then I send the request. In the Response tab, there are no matches for Welcome Back. This tells us that the first character of the password is not the letter A. Checking every position against every possible character manually would take far too long. Instead, I'll send the request to Intruder and automate the process. In Intruder, I select the first number 1 inside the substring function and click Add. This becomes the first payload position, the character position within the password. Next, I select the letter A at the end of the payload and click Add again. This becomes the second payload position, the character we're comparing against. At the top of the window, I change the attack type to Cluster Bomb. This attack type tests every possible combination of values from multiple payload positions. In our case, Burp will test every password position against every possible character. Now I switch to the Payloads tab. For Payload Set 1, I choose the number's payload type. I leave from Set to 1 and enter 20 in the To field. This tells Burp to test character positions 1 through 20, covering every position in the administrator's password. Now I switch to Payload Set 2. For this payload, I select the Brute Forcer payload type. The Brute Forcer payload generates all possible combinations from the selected character set. Since we're limiting the payload length to 1 character, Burp will test each lowercase letter from A to Z and each digit from 0 to 9, one at a time. In the min length and max length fields, I set the value to 1 because we only need to test 1 character in each request. Now I click Start Attack. The screen shows the attack in progress. For each password position, Burp tests 1 character after another. It starts with A, then B, then C, and continues through the remaining letters and digits until every possible value has been tested. I've skipped the rest of the attack because sending all of the requests takes some time. In the next part, we'll examine the completed results and use them to recover the administrator user's password. The attack is now complete. The finished message at the bottom of the window confirms that intruder has finished sending all requests. To quickly separate the successful results from the unsuccessful ones, I click the length column header and sort the responses by their size. We can see two main response lengths, 11,608 and 11,547 bytes. I select one of the responses with a length of 11,608 and open the Response tab. In the search bar, I search for Welcome Back. Burp finds one match and highlights the message in the server's response. This tells us that the condition evaluated to true for this request. In other words, the character being tested matches the actual password character at the position. Now I select a response with a length of 11,547 and search for Welcome Back again. This time there are no matches. This means the condition evaluated to false, so the tested character does not match the password. So responses with a length of 11,608 contain the Welcome Back message and represent the correct position and character combinations. Responses with a length of 11,547 correspond to incorrect guesses. After sorting by length, all of the successful results are grouped together, making it much easier to reconstruct the password. I now open the Notepad file where I previously recorded the results. The first row contains the password positions, numbered from 1 to 20. The second row will contain the character found for each corresponding position. Let's look at a couple of examples. In the first result, payload 1 contains the value 2 and payload 2 contains the letter C. This means the second character of the password is C, so I write C in position 2 in my Notepad file. In another result, payload 1 contains 10 and payload 2 contains the letter D. This tells me that the 10th character of the password is D, so I write D in position 10. I continue matching each password position with its corresponding character until all 20 positions have been filled. Now I copy the completed password and return to the browser. I click my account, enter administrator as the username, paste the recovered password, and click Login. The login is successful. The page displays the username administrator, confirming that we've successfully logged in to the administrator account. Finally, the message "Congratulations, you solved the lab" appears, confirming that the password was recovered successfully and the lab has been completed. We've successfully completed the PortSwigger Lab Blind SQL Injection with Conditional Responses. In this tutorial, we confirmed the vulnerability by observing changes in the application's response, determined the length of the administrator's password, and used Burp Suite Intruder to automate the extraction of each password character. Finally, we logged in as the administrator using the recovered password and solved the lab. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.